Schizophrenia, as is from now on, is a severe mental condition. It fractures the sense of self and of reality and impairs different aspects of a person's life, including personal, social, and occupational functioning. It has an intriguing constant rate, affecting 1% of the world population, although it leads to mortality at early age and reduced fertility. It certainly has a genetic base, but environmental variables such as urban life, migration, advanced paternal age, feminine prenatal complications contribute to its onset and development. According to the ICD-11 and DSM-5 classification systems of mental disorders, SE has the following symptoms: delusion, hallucinations, formal thought disorder, FTD, disorganized speech, and distortion of self-experience. Negative symptoms such as anhedonia and apathy and psychomotor disorganization are also observed. The literature on language centers on FTD and disorganized speech. The problem with formal thought disorder is that it's hard to define. Most importantly, it is observed through language. Disturbances in structural thinking are perceived and analyzed through speech. The more linguistically structured a speaker is, the lower the probability of him or her having FTD. Thus, the symptom of formal thought disorder might be equal to language disorder. The shape graph below, developed in Guerra's research, gives us a good macro view of the grammatical impairments observed in SC, showing how grammatical categories are affected. High occurrence of pronouns and low occurrence of complementizers seem to be grammatical markers of SC in many different languages, indicating issues at the DP and the CP syntactic domains. At the DP level, it is observed more use of first-person singular pronoun and of third-person pronouns without clear reference. SSE speakers also have a preference for no pronominal forms in pro-drop languages, and they avoid definite DPs. When definite DPs are used, they tend to be semantically anomalous. At the sentential level, SSE speakers tend to use more matrix clauses, presenting difficulties with the semantics of embedded sentences. Also, they seem less sensitive to grammatical errors in structures with A-bar movement and ellipses. In the next presentations, we will highlight some of our new contributions. First, João de Miranda e Silva will discuss how large language models can be used to gain knowledge of language in SC. Then Mônica Chaves will talk about language in LSD. LSD is a psychosis mimicking model of SC. But the question is, does it affect cognition, particular language, in the same way that SC does? Thank you, and enjoy it.
Hello, I am João Victor, and I'm going to continue from where Cilene left the presentation. Well, she has already presented that schizophrenia has some language disturbances that cause structural deficits or structural impairments very broadly. They usually impact functional categories and grammatical operations. In this line of research, there's been an emergence of computational approaches to classifying schizophrenia through language. This is what we're going to present. We aim at presenting an integration between representing linguistic structure in a way that is aligned with formal linguistics and at the same time using state-of-the-art computational methodologies for our natural language processing in order to systematically identify linguistic patterns in schizophrenia. So the first thing I want to present is, well, how to represent language computationally. Nowadays, the state-of-the-art way of representing language is through tokens, because these are the units that are fed to large language models, which are the state-of-the-art algorithms for processing language. Tokens, in the case we're going to present, are very aligned with morphology concepts because they're not entire words and they are not also based on characters, but actually they're based on subwords, which are parts of words that usually represent roots and affixes. These tokens, they are represented as a dense vector of numerical values, and these numerical values are what we call embeddings, and they are what a large language model actually sees and how it conceptualizes systematic linguistic patterns across languages. So these embeddings, they carry a lot of the information regarding linguistic elements that a large language model seeks. How does a large language model actually um, is trained and learns linguistic patterns across a specific language? Well, there's more than one way of doing so, but we're going to introduce the way that BERT does so. BERT is the name for bidirectional encoder representations from transformer, which is a large language model deployed by Google. It is the model we're going to use in our presentation. So BERT takes an input and masks a token from this input, and then tries to predict this token based on its surrounding tokens. And then by adjusting its weights uh, in relation to, well, getting predictions right or wrong, is the way that BERT actually learns patterns and adjusts its embeddings value, the values of its embeddings. Well, a nice part of the pre-training process of BERT is that, well, now it is publicly available as a free-to-use model that comes already pre-trained and that you can fine-tune for downstream tasks. So what we did was we took this model BERT, this model BERT, which was already pre-trained, and we fine-tuned it to classify schizophrenia across a set of 31,278 posts from the social media platform Reddit. These posts were equally split between users who self-declared as having schizophrenia and users who did not self-declare as having any kind of mental disorder. And we chose Reddit because it is already segmented in topics of discussion, so it's easier to find users discussing schizophrenia, and at the same time because it has an accessible API. We manually verified all self-declarations, and we used these post sample, as I have already mentioned, to fine-tune a BERT model, and it achieved an accuracy of close to 70%, which we interpreted as being suitable for further explorations based on the relation, aiming at analyzing the relation between lexicogrammatical variables across post samples and the BERT model's classifications, because 70% is higher than a classification by chance, which would result in an accuracy around 15%. So what we did to find correlations between lexicogrammatical variables present in our samples and the BERT model's classifications of schizophrenia was we used Spacey, which is a neural network framework that is publicly available and is state of the art it is an efficient state of the art way of classifying language and processing language and overall. It provides not only grammatical categories, such as pronouns and verbs for words, but it also categorizes dependency relations, such as subject and object, complements of prepositions, and other categorizations. A part of that, we also added external rules to Spacey's inherent classifications to create more categories or refine categories. So, for example, Spacey does not have a representation of bare nouns, but bare nouns were interesting to us. So we added external rules to species inherent classifications to create this to check sentence structure and nominal structures and create this new category and called bare nouns. They also created a function that traverses through species dependencies classifications, and it counts dependency relations in order to provide a measure of embedding depth, which was also interesting to us. And we used such categorizations as variables for further explorations of correlations between their presence and our fine-tuned models classifications. So the most prominent results derived from our set of explorations between lexicogrammatical categories and the model's outputs stem from Markov blankets and input masking approaches. Markov blankets are graph theory approaches in which you try to derive a minimum set of candidate features that can causally account for the prediction of a target variable. We treated the grammatical categories stemming from Spacey and our additional external refinements of its categories as candidate features, and the model's predictions as target variables. And what we identified was that there was a minimum set of predictions of variables that could account for correct predictions of schizophrenia, and they were composed of the following variables: indefinite determiners, first person pronouns, and overall nouns, and also WH elements. And then we also performed an input masking approach, which was based on choosing a lexicogrammatical categories and substituting it in all samples of our test dataset for the token mask, which is the token that was used during BERT's pre-training. And what we try to see is if the explicit presence of a specific lexicogrammatical category would perturb the BERT model's probabilities of overall probabilities of samples being related to schizophrenia classifications. And what we observed was that indefinite determiners and the possessive Fs, such as in Lucy's car, were related to prediction of schizophrenia, and also overall nouns and pronominal forms were related to classifications of control samples. Therefore, we can see that there is some kind of alignment between results derived from the literature more aligned with formal linguistics and results derived from computational approaches when we use formal linguistics to refine the computational representation of language, and at the same time to interpret the results derived from experiments that use such representations.
Hi, I am Monica, and I will talk to you about the research we are conducting right now. As already mentioned, in the first stage of our research, we focus on how grammar is affected by schizophrenia, comparing narratives of two groups, people with schizophrenia and control group, people with no previous history of psychosis. Now, we are examining narratives of healthy individuals under two types of treatment, 50 micrograms of LSD and placebo. In this stage, we are collaborating with a group of researchers from Unicamp, who conducted the experiment and shared the narrative they collected with us. This is a randomized, double-blind, placebo-controlled crossover study in which 24 healthy subjects with no history of psychosis were randomly assigned to two treatments in two different sessions 14 days apart. During the sessions, participants were asked to ingest either a placebo or LSD and were asked to tell a story about 4 images presented on a sequence of slides. Both sessions followed the same routine. At 9 o'clock, after baseline measures were taken and before the ingestion of either placebo or LSD, participants were presented with the first set of 4 slides and had 1 minute to tell a story about each image presented to them. After that, at 9:30, they were asked to ingest LSD or placebo. A new set of slides were presented to them 2 hours after the ingestion, and again at 4 and 6 hours after the ingestion. There were 2 sets of slides, A and B, for each time, 0 hours, 2 hours, 4 hours, and 6 hours after the ingestions. The images were always of the same type, 2 color-happy images, 1 black and white abstract image, and 1 slide presenting an impossible scenario, such as what would be the consequences of gravity were halved. In the below images, you can see examples of what the participants saw. They collected a total of 960 narratives, and our job was to screen and annotate sentences and subjects' pronouns in each narrative. So far, we have analyzed the narratives collected 2 hours after the ingestion, which is the peak of LSD effect. As the examples show in the yellow box below, we tagged matrix and embedded clauses, truncated sentences, grammatical such as ellipses and reduced relative clause, and ungrammatical truncated sentences. We also annotated subject pronouns new and overt, and third-person referential and non-referential pronouns, as well as if they were anomalous or non-anomalous. As you can see from the presented graphs, no significant difference was found between the groups with the placebo and LSD. Nevertheless, our preliminary result points to a strong tendency at sentencing at nominal levels. Under the effect of LSD, people produce more matrix sentence, fewer embedded, more truncated, both anomalous and non-anomalous, more new subject pronouns, and fewer new third-person referential pronouns. According to our preliminary results, the LSD psychosis model is not a perfect match to what is observed in schizophrenia. In other words, LSD does not seem to affect grammar in the same way that schizophrenia does. Just like schizophrenia, grammar under LSD shows a tendency to produce more matrix sentences and more new subjects pronouns. However, unlike schizophrenia, we found that under LSD there is a tendency to produce more grammatical truncation and fewer new third-person referential subject pronouns. Therefore, we emphasize that although no significance was found, the higher production of truncated non-anomalous sentence and the lower production of new third-person referential pronouns under LSD at T1 at 2 hours after the ingestion, which is the peak of LSD, contrasts with the significantly lower production of truncated non-anomalous sentence and the higher production of new third-person referential subject pronouns we found in schizophrenia. These results also suggest that although language becomes simpler and more disconnected under LSD and schizophrenia alike, LSD, differently from schizophrenia, does not affect complex grammar. Thus, our preliminary results suggest that LSD has a lighter effect on grammar compared to schizophrenia. I would like to thank you very much for paying attention to our presentation and giving credit to our research. Obrigada.